Did you ever try to synchronize data that is stored on multiple devices with a centralized database? Well, it might be tricky. That is how I wanted to start this video, but then I realized that it's not that tricky. Personally, I have thinking of a web developer, and when I need to transfer data from a client to a server, the first thing that comes to my mind is the request-response model. And it's fine, because this approach is pretty straightforward one, but it doesn't mean that any other approach should be way more difficult than that. They're just different. So, hi everybody and welcome to my channel. In today's video, I'm gonna share with you the latest updates on my app, as well as the approach that I chose for the data synchronization. So the first major update is this ability to remove or archive any money map item. To trigger this functionality, you need to do a long press on any money map item, for example, this commuting one. And after that you need to press this minus button. Here you can see the two options. Actually, you can delete this money map item, and here you can see the consequences of that. So removing this expense category will delete all transactions associated with that. Often you don't want to do that because all the data you had previously tracked will be removed. And for the cases when you just want to simply hide the money map item, you can choose archive. Then you press archive and it will be gone from this money map screen. And after adding this feature, I started thinking how do I undo that? And I added this pretty simple screen in the settings. It's called archived accounts. You can go here and you can swipe. This is an information about how you can do that. You can swipe and you can press an archive and it will be shown here again. The next update is related to the internal structure of database, of tables in the internal SQLite database. Previously, I had an approach where I would use the two ID fields for each table. For example, the client ID field will be always filled with the data because it is created on the client, and to understand if this data was created on the server, I would use this ID, which is, as you can see, a nullable field. And if this ID field has the data, then I understand that it was created on the server. But honestly, it's lame, and I gave up on this approach. And what I have now, I just moved to UUID. So every table in my database, my internal SQLite database and the server database have UUID for ID field. And it is really convenient when you work with distributed systems. So it's better to guarantee the uniqueness on the client, and then this ID can be reused on the server. The next change is also related to the internal structure of my databases. I have added this deleted add field because if you want to remove anything on the client, it would be horribly difficult to implement the synchronization flow. And when you have this nullable deleted add field, it is easy to understand if this specific row was removed, and every part of the app, the server and the client, can understand that. And now we're moving to the most difficult part of this app, at least I think so. It is a data synchronization. So let me remind you the main purpose of that. I want to introduce the feature that would allow multiple users use the same account and basically add, remove, update, and whatever any data on the client side. And occasionally this data will be stored on the centralized database. And the most common problem is resolving conflicts. And what do I mean by conflicts? Let's say there is a family of two people, and each of them has the same account but two different devices. And here you can see the history of already existing transactions made by this family. Now the person one understands that he messed up with this health transaction, and he wants to update the amount from 75 to, let's say, 72. At the same time, the person two wants to update the same transaction, but from 75 to 76. And how do we decide what change should be applied? Actually, there are more than one strategy to consider, and for my app, I decided to use the strategy that is called the last right wins. The last means the most recent one, and to understand whom change was the most recent one, there is a mechanism that is called HLC. It stands for Hybrid Logical Clock. Basically, it consists of two parts. The first part is the Unix timestamp, and for cases when more than one change was done at the same time on the same device, there is a second part of this clock mechanism. It is basically like a version. So if you have only one change that was made at the same time to the same row, it would have this version equal to 0. And if there are two changes that were done for the same row on the same device, this version would equal to 1. So 0 plus 1. So this concept might be a bit overwhelming, but it is not really difficult as it might seem. So in future time, I'm going to implement this HLC mechanism and apply it to my application. And once it's done, I will definitely show the result of the implementation. I will share my thoughts on that, maybe some mistakes that I'm probably going to make, but hopefully not. Thank you for watching this video and see you next time.